Hi everyone, welcome to this C programming lesson. I'm your instructor for today and we're going to talk about recursion, one of the most interesting topics in C and also one of the most confusing if you're hearing it for the first time. But don't worry, in this video we will go to recursion step by step. By the end of this lesson, you will be able to understand the basic definition of recursion in C, explain how recursion works step by step, including the role of the base case and the recursive case, analyze the flow of recursive function using simple and beginner-friendly examples. Lastly, identify common mistakes when using recursion and learn how to avoid them. Let's begin with the most basic question. What is recursion? Recursion is simply when a function calls itself. Yes, that's it. A function that keeps calling itself over and over again until it reaches a point where it needs to stop. This stopping point is called the base case. Recursion is often used when a problem can be divided into smaller versions of the same problem. Instead of using long loops or repetitive codes, you let the function repeatedly solve smaller pieces. To imagine recursion, think of two mirrors facing each other. You will see that reflection keeps repeating. A set of Russian dolls. When you open one, and then there's a smaller one inside, and so on. Or breaking down big tasks into smaller tasks. Every recursive function has two important components, the base case and the recursive case. The base case is the condition that stops the recursion. Without this, the function will call itself forever and your program will crash. The recursive case is the part where the function calls itself again, usually with a smaller value. The recursive case keeps the function running until it reaches the base case. Without a base case, the program would keep repeating forever, causing what we call a stack overflow error. Now, how does recursion actually works? The flow is always like this. Call, 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 base case, return, return, return. Meaning, each function calls waits for the next one to finish. You can imagine this like stacking plates. You keep adding plates on top, that's the recursive call. But when it's time to remove them, you remove from the top first. And that's the base case. After that, every function starts returning back upwards. Here's a simple stack visualization. At the bottom, we have the print number 3. It goes print number 2, then it goes print number 1, then it goes print number 0. And this is the base case. Once the base case is reached, the program finally starts returning back up. This is how recursion manages its memory through the call stack. To understand it clearly, let's look at some simple examples. We'll start with the easiest one, then gradually move to the slightly more advanced examples. Okay, for our first example, we have a very simple recursive function called print number. This defines the function named print numbers that receives one integer value n. This is the base case. It stops the recursion when n becomes 0. If this line is not here, the function would continue forever. This prints the current value of n on the screen. This is the recursive call. The function calls itself with a smaller value, n minus 1. This continues until it reaches the base case. If you call print numbers 5, the output will be the function prints the number first, then keeps itself with a decreasing value. The sequence stops when n becomes 0. Next example is factorial, a classic recursion problem. This defines a function named factorial that returns an integer. This is the base case. By definition, the factorial of 0 is 1. This is the stopping point of the recursion. This is the recursive case. The function multiplies n with the factorial of n minus 1. This repeats until the base case is reached. Calling factorial 5 produces 5 times 4 times 3 times 2 times 1 equals to 120. The recursion breaks the problems into smaller factorials until it reaches 0. After reaching the base case, the number multiplies back upward. Now let's look at the Fibonacci sequence, which is slightly more advanced because each function calls itself twice. This line defines a function that returns the nth Fibonacci number. First case, Fibonacci 0 is 0. Second base case is Fibonacci 1 is 1. The recursive case, Fibonacci of n is the sum of the previous two Fibonacci numbers. The function calls itself twice. The sequence is 0, 1, 1, 2, 3, 5, 8. The sixth Fibonacci number is 8. The recursion breaks the problem until it reaches the base case, 0 and 1, then adds value as it returns. Next, we have the sum of an array using recursion. This defines a function that returns the sum of the first n elements of the array. This is the base case. If there are 0 elements left, the sum is 0. The recursive case adds the last element, array n minus 1, to the sum of the rest of the array. The function reduces the problem size by decreasing n. For the array 1, 2, 3, 4, 5, the output is 5 plus 4 plus 3 plus 2 plus 1 is equals to 15. The recursion processes one element at a time until no elements are left. The last example is a very simple display function. This defines a function that displays a message multiple times. This is the base case. So it stops the function when it reaches 0. This prints the message with the current value of n. And this is the recursive case. Repeats the process with a smaller number. For display 3, the output is the function, prints the message, then it calls itself until it reaches 0. Recursion is powerful, but it can also be tricky if you're not careful. So let's quickly go over some common mistakes that usually beginners make. First, forgetting the base case. If you don't include a base case, the function will keep calling itself forever and it will cause a Stack Overflow error. Second, writing the wrong base case. A small mistake in the condition can make your function stop too early or too late. Third, not reducing the problem correctly. If your recursive call should always get closer to the base case, if not, the problem will never stop. And lastly, finally, misunderstanding recursion flow. Remember, recursion uses the call stack, so it goes deeper and deeper and only returns value after reaching the base case. Alright everyone, that's all for today's tutorial on recursion on C programming. We learned what recursion is, the basis and recursive cases. We walked through 5 practical examples. We also covered common mistakes to avoid. I encourage you to practice recursion by writing your own programs like factorials, Fibonacci numbers, summing array, or displaying message recursively. If you found this video helpful, don't forget to like, share, and comment down below. Also subscribe for more future programming tutorials. Thank you for watching and I'll see you soon. Bye!